All right, in this worksheet, we're going to go through the solutions of your home worksheet that covered 8A and 8B. So just quite basic probability, but it is a bit tricky. Okay, so remember, I do give you tricky questions because you need to think. Okay, there's no point in giving you questions that are routine and easy for you. You need to have questions that get you to think about how you would do it. Okay, so Year 10 class contains 12 boys and 14 girls. Complete the following two-way table using the events boys and girls. So remember, when you do a two-way table, in this bottom cell here is all, you always put in the number of people. So in the class, we have 26. Okay, we have 12 boys and 14 girls. Now, the other bits of information we can put in, so 12 boys, B representing boys, B dash, or the complement of B is not a boy. Okay, so we have 12 boys there and 14 girls. Okay, so when you think about it, you can't have someone who is both a girl and a boy. I'm not going to get into different sexualities here, so we'll just say you can only be either a girl or a boy. And you can't be not a girl and not a boy. Okay, so you have to be one or the other. Okay, so we can just complete it. So if you're not a boy, there's 14, so obviously you're a girl. And if you're not a girl, you're a boy. And then we just need to complete this. So the number of girls who aren't boys, 14, and the number of the boys who aren't girls is 12. So a little bit different, but it's good to get you to think, because the name given to these types of events are, and I know some of you had trouble thinking about this, but it's mutually exclusive. So when two events have nothing in common, they're mutually exclusive. Okay, so remember, in your Venn diagram, your circles don't overlap. Okay, so you can have girls and you can have boys, but you can't have both someone who is both a girl and a boy. All right, let's move on. I should have kept that because I need to answer these questions now. Let's see if I can do it without that. Okay, if the teacher selected a student at random from this class, determine the probability of the teacher selecting a boy. So there's 12 boys in the class. We're looking at the probability. So if probably just get in the habit of circling whether it's asking for the probability or the number. So this one's a probability. So 12 over 26, and we can simplify that to 6 over 13. Try to get into the habit of simplifying your fractions. Probability of a girl, obviously, is 14 over 26, which is 7 over 13. Okay, so these are the complement of each other. What that means is they add up to 1. Either a boy or a girl. Okay, so that's going to be 1. Okay, so if I randomly selected someone, obviously I'm going to get either a boy or a girl. I can't have neither. And neither a boy nor a girl is 0. So this is it will happen, it definitely will happen, and definitely won't happen. Okay, sorry, let's clear that. Whoops, keep pressing the wrong buttons. Okay, question 2. From the 12 boys in the class, 4 like to play with Lego, 9 like to play with marbles, and 2 like to play with both. So represent this information in a Venn diagram. Okay, so Venn diagram, and I've always said I prefer a two-way table, but let's draw it like this. Okay, so we've got 12. So when I add up my numbers, I should get 12. Okay, if they don't add up to 12, then you've made a mistake somewhere. Okay, always start with how many like both. So 2 like both. And let's put a Lego here and marbles here. So 4 like to play with Lego and 2 of them like to play with both. So that means only 2 like to play with Lego but not marbles. And 9 like to play with marbles. So already 2 like Lego, so that leaves 7 there. And the neither, just add them up and take it away from 12. So we've got 11. So there's 1 who likes neither. Okay, so based on this information, determine the following. The number of boys, so this time we're looking at the number of boys who don't like to play with Lego. So we've got 4 boys who like to play with Lego, so that means 8 don't like to play with Lego. The number of boys who only like Lego and not marbles, so 2. The number of boys who like either Lego or marbles, so I always find it's easier to take away what you don't want, so 12 minus 1 is 11. And I don't know whether there's any more questions coming up, so let's just scroll. No, okay. So this one here, remember, was asking for the number. Okay, so question 3, from the 14 girls in the class, 6 like to play with Lego, 7 marbles, and 4 both. Based on this information, determine the following. So this time we're looking at probabilities of girls who don't like to play with marbles. So before you start, I think it's a good idea to either represent it as a two-way table or a Venn diagram. And it doesn't take long to do. So we're just going to have marbles, not marbles, Lego, not Lego. I know there's 14 in the class. 6 like to play with Lego. 7 like to play with marbles, and 4 like to play with both. And then it's just a matter of filling it in. Okay, so remember your rows should add up and your columns should add up. Okay, so the probability of girls who don't like to play with marbles. So there's 14 girls. We don't like to play with marbles, so not marbles is 7. So that simplifies to a half. The probability of girls who only like marbles and not Lego, so like marbles but not Lego, is 3. Again, that can't be simplified. The probability of girls who like neither Lego nor marbles, so that's here at 5. Okay, so we can't simplify that one either. All right, last page. So this one here, I thought was quite a good question. And I thought if you didn't know how to work with probability, you could easily answer this question by drawing all 26 students. It would be quite time consuming, and you probably shouldn't be doing that at year 10. But when you look at problems like this, you've got to think, well, I'm having a bit of trouble answering it using, the processes shown to me. Let's think of another way I can do it. So let's think about the 14 girls and the 12 boys, and maybe write underneath them who likes what. All right, so anyway, let's move on. The teacher selects one of the students from the class, given the information given in the previous questions, to determine the following. So each of these is going to be out of 26. This is going to be hard because I'm going to have to keep scrolling. But the probability that they like Lego. So you add up how many like Lego. So let's just go back up. So of the girls, 6 like Lego, and of the boys, 4 like Lego. So we're going to have 10 over 26. And that simplifies to 5 over 13. Okay, the next one, the probability of Lego and marbles. Okay, so this time we need both of them. So 4 girls and I think it was 2 boys. So 6 over 13. 6 out of 26, sorry. 6 over 26, which gives you 3 over 13. This is the probability of a boy and marbles. So if we go back up, we just go to the boys. Sorry, was it and or and? Sorry. From the 12 boys in the class, how many 9 like to play with marbles? So we have 9 out of 26 for that one. And that can't be simplified. This one here is a probability of a girl or Lego. So when you think about it, we want the probability of getting someone who is a girl or someone who likes Lego. And you can also have both. Now, we can do this 2 ways. So I'm going to do that here because there's a little bit of working out. What we're going to be doing soon, and we've probably done it before you watch this video, is use the addition rule of probability. So that means the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Now, what this is basically saying is we're adding A, adding B, and because we're doubling up, basically, when you think about the Venn diagram, if we're adding A and then we're adding B, we're actually including that middle bit twice, so we've just got to take it away. Take away one of them, so we're only including it once, which is what we want. So for this one here, we want the probability of a girl or Lego. So the probability of a girl was 14 over 26. The probability of Lego, now don't write 5 over 13 because if you don't have a calculator, you won't be able, oh, well, you can, but it's just easier to add when you've got the same denominator. And then the probability of a girl and Lego, so I can't remember that off the top of my head, so let's just scroll up. So a girl, 6 like to play with Lego. Here we go. So, oops, and I did plus there. Can I take that away? Okay, take away 6 over 26. So we have 24 minus 6 is 18 over 26, and that simplifies to 9 over 13. Another way you can do it, and remember you can always subtract your complement from 1, so we can do the 1 minus the probability, and when you think we want a girl or someone who likes Lego, so what's the probability that someone is a boy? Sorry, I'm just thinking. Just give me a sec. Got to think. I'll press pause. Okay, sorry. Just thinking. So basically, with these girls, you're including girls who also like marbles, and in this Lego, you're including boys who like Lego. So we're only excluding boys who like marbles, and basically boys, oh actually, let's just delete that for a sec. Boys who don't like Lego, because it's not, because if I put marbles there, not Lego is not necessarily marbles, it's not one or the other, because you can be both not Lego and not marbles. So the probability of a boy who doesn't like Lego, we go back up here to the boys. Okay, so when we did our Venn diagram, we had 7 who just liked marbles and 1 who liked neither. Okay, so if you can think about our Venn diagram, where are we? Down here. So that's going to be 7 plus 1. So it's 1 minus, so 7 plus 1 is 8 over 26. So this 8 represents the number of boys who don't like Lego. And if you had written the Venn diagram or your two-way table, you would see that. Okay, so then 1 minus 8 over 26. If it's easier, you can change the 1 to 26 over 26. It's the same thing. And that gives us the same answer. Okay, 18 over 26, which simplifies to 9 over 13. So 2 ways to do it. I think it's always a good idea to remember, if it's too difficult to do one way, think about, well, can I just subtract what I don't want from 1? This addition rule is pretty straightforward to use as well. If I was doing it, I don't know which one I would use. I think that to me, they're both equally fine, but personal preference. All right. Oh, we had one more. So I knew I had another question. Okay, so the probability of a boy and not Lego. Oh, we just did that one, didn't we? Okay, so that's 8 over 26. That would have been easier if that one came before that, because then you could see you could just subtract. So this is basically the opposite of this in a way. Okay, and that simplifies to 4 over 13. Cool. Bit longer than I expected, but well done, girls. Good stuff.